Which is better, on-policy or off-policy learning and reinforcement learning? Imagine teaching a robot to navigate a maze. Should it learn only from the paths it takes, or can it learn from past attempts and other routes? That's the core of deciding between on-policy and off-policy learning. Both are ways machines learn from experience, but they do it differently. Neither is always better. It depends on what you want the machine to do and the environment it's in. On-policy learning means the robot learns from the actions it actually takes while following its current strategy. It updates its knowledge based on what it does now. For example, if it chooses a path and finds a dead end, it learns to avoid that route next time. This method is straightforward and stable because it learns from its real experience. But it can be slow because it only learns from the current way it is acting, which might include mistakes or suboptimal choices. Off-policy learning, on the other hand, allows the robot to learn from data generated by a different strategy. It can learn from past experiences, even if those actions weren't the robot's current plan. For example, it can learn from previous attempts or data collected by other robots. This approach can be faster because it uses more data, including simulated or past experiences. It's more flexible and can find the best route more quickly, especially in predictable environments. However, off-policy learning can be trickier to set up. It needs careful handling to avoid mistakes like learning from bad data or making unstable updates. It often requires more complex algorithms to keep the learning process steady and reliable. In real-world applications, off-policy learning is useful when you have lots of data from different sources. For instance, training AI models like ChatGPT or image generators like DALL-E and Midjourney often involves learning from large datasets collected under various conditions. This makes off-policy methods more efficient in such cases. On-policy learning might be better when safety and stability are key, like in robotics or autonomous vehicles. Since the robot learns from what it is doing right now, it reduces the risk of unexpected behaviors. Understanding these differences is important when designing AI systems that interact with humans or the environment. Off-policy methods can raise questions about data quality and bias, affecting fairness and transparency. On-policy methods are easier to interpret but may take longer to adapt. In the end, choosing between on-policy and off-policy learning depends on the specific task, the environment, and what you value most: speed, stability, or safety. Both have their strengths and are suited for different kinds of problems in the world of reinforcement learning.